Hi, everyone. Welcome to our new unit on quadratic functions. And before we get started with the quadratics, I just wanted to take a minute to review linear and nonlinear relations. So given the relation, x represents the independent variable. And when graphed, it's on the x-axis. And the y variable represents the dependent. And this variable is graphed on the y-axis. So a table of values can be used to produce coordinates that can be plotted on a graph. There's no restrictions on the number of outputs or y values that can correspond to a single input or x value. So what I want to do here is go ahead and complete each table, plot the points, draw a line or a curve of best fit through the data points. When complete, and determine if the relation is linear or nonlinear. So if we use our table of values, what we do is, for example, for -3, we will take our relation x minus 1, and we will sub in -3 minus 1, and we'll get -4. We do that all the way down the line for all of the x values, and we see what y values come out. So we'll do another one. Y is equal to -2 minus 1. Here, y is equal to -3. And one more, y is equal to -1 minus 1. Y is equal to -2. And we start to see a pattern. So I'm going to go ahead and fill in the rest of the table of values. This will go to -1, 0, 1, 2, 3, and 4. Now what we want to do is find the first difference. So the first one is done for you. And we had -5 minus -6, so the one above it. So let's fill in what the next one would be. We would have -4 minus -5. Simplifying that, we would get 1. In the next line, we would have -3 minus -4. Simplifying that, we would get 1. -2 minus -3 also give me 1. -1 minus -2 equals 1. 0 minus -1 is 1. 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. And finally, 4 minus 3 is 1. So this column is what we call the first difference. And as we can see, the first difference, all the values are 1. So let's go ahead and plot some of these points. We can start with -5, -6, -4, -5, -3, -4, -2, -3. So hopefully you can start to see the shape that this graph is coming up with. So we say since the first differences are constant, they're constant of 1, then the relation is linear. We'll do that again with our second example, y equals 1/2 x plus 1. And we're going to go through again here, and we're going to fill out our table of values. And we'll just do a couple of examples and then we'll see our pattern. So again, let's start with -3. Y is equal to, we substitute 1/2 times -3 plus 1. Y is equal to negative, let's say 1.5 plus 1. Y is equal to negative 0.5. So I'll put that in the table. For the next one, y is equal to 1/2 times -2 plus 1. Y is equal to -1 plus 1. Y is equal to 0. Y is equal to, we're going to plug in -1 this time, plus 1. Y is equal to 0.5. And we're going to keep building from there. So sorry, -3, that should be a negative 0.5. So we see maybe that this table is going up by a constant value. This one should be 2.5, 3, and 3.5. We go through and we check our first differences. We'll have negative 0.5 minus -1. That will give me 0.5. 0 minus negative 0.5. That will give me 0.5. 0.5 minus 0 is 0.5. 1 minus 0.5 equals 0.5. Okay? And we can already see in this pattern that they're going to be the same, or the first differences are going to be the same all the way down. So let's plot some of these points. Let's go with -4, -1. I'm only going to do the whole numbers, so I don't work with the decimals. Next one will be -2, 0, 0, 1, 2, 2, 4, 3, good. So since our first differences, again, here, they are constant being 0.5, this relation is also linear. Let's take a look at our last example. We have y equals x squared minus 9. We'll go ahead and start to plug in some values. So y is equal to -2 squared minus 9. -2 squared is 4. So here y equals -5. I'm going to scroll to the bottom to do a few more examples. And we're going to plug in -1 next. So y is equal to -1 squared minus 9. Y is equal to 1 minus 9. Y equals -8. Y equals 0 squared minus 9. Y equals -9. Y equals, substitute 1 here, -9. Y equals 1 minus 9. Y equals -8. Next, we'll sub in 2, so y equals 2 squared minus 9. Y equals 4 minus 9. Y equals 5. Sorry, -5. Then we have y equals, let's substitute 3 squared minus 9. 3 squared is 9 minus 9. Y is 0. And finally, we'll have y is equal to 4 squared minus 9. 4 squared is 16 minus 9. Y is equal to 7. Okay, so we used our substitution to find all the y values that correspond with these x values. Now let's take a look at the first differences. So we have 0 minus 7, that gave me negative 7. The next one will be negative 5 minus 0, and that will be negative 5. Going down the line, negative 8 minus negative 5, it's going to give me negative 3. Negative 9 minus negative 8, going to give me negative 1. Negative 8 minus negative 9 is going to give me positive 1. Negative 5 minus negative 8 is going to give me 3. 0 minus negative 5 is going to give me 5. And finally, 7 minus 0 is going to equal 7. So what do we notice here? That the first differences are not the same. Let's go ahead and start plotting some of these points. So we have negative 3, 0, negative 4, 7, 1, 2, 3, 4, negative 2, negative 5, negative 1, negative 8, 0, negative 9, 1, negative 8, 2, negative 5. And so we start to see this different kind of shape. 3, 0, and then 4, 7. And we can see that a line is not going to fit these points. So I'm going to try to draw a smooth curve. And this shape is actually called a parabola. So since the first differences are not constant, the relation then is non-linear. And this is actually quadratic. So that leads us into the next lesson.